Hey guys, welcome back to my channel, Automate to Alleviate. And today I'm just going to be going over the course that I recently completed. I think I completed about 2 months ago. And that course is Mathematics and Machine Learning, Linear Algebra. As the title suggests, the course gives you a understanding of the math behind machine learning, which is really useful because it's quite simple to start in machine learning nowadays, because you could simply download different packages such as SciPy, TensorFlow, etc. And you don't really need to know the math as long as you can program and you understand the different methods and how to instantiate a class, etc. Just how to program in general. You're not really going to have much of an issue actually writing the code and getting the algorithms working, which is fine. But I think sometimes a lot of people who are in that scenario yearn for a deeper understanding of the math, because the field is rapidly changing, and understanding the fundamental blocks that actually machine learning is built upon is going to outlast knowledge of a specific library. Again, I'm not saying you need to know the math, but I just think that it can be a little useful. So I'm just going to quickly go over the course just so you guys know what to expect if you're interested in taking it. I will say, do not take this course if you're interested in learning pandas, NumPy, etc. Um, of course, it's in the realm of data science because machine learning is heavily used in that field, but don't get that confused with the fact that this is just mainly focusing on the math. So, anyways, now that I've got that out of the way, uh, week one just talks about vectors. So, obviously, vectors are just containers that hold numbers. It explains why we actually use linear algebra. Of course, it's to solve linear equations. That's the main use case. And throughout the course, it just talks about different operations you could perform, which are known as linear transformations. Linear transformations are just simply things like multiplying two vectors, multiplying two matrices. Um, those are examples of linear transformations, adding, subtracting, etc. Whenever you basically alter uh, a vector or matrix, you're essentially doing a linear transformation. Talks about eigenvectors. Eigenvectors are basically just vectors that don't change in direction when a linear transformation is applied. So it talks about that. And overall, a really great thing about the course too is, in addition to the practice quizzes that you can see here, there's also actually programming quizzes. And the great thing about these programming quizzes is it really helps solidify your knowledge, because you're forced to take what you've learned and actually apply it to a real world scenario. One example of this real world scenario would be an image that's on an angle, and you need to basically use the you need to use linear algebra to alter the angle of the image so that it's upright, because it's essentially tilted prior to you actually inputting the code to solve and find the solution. So that was really great. That really helped me kind of get an better understanding that I could also use vectors to describe angles, and I could apply transformation to those vectors to alter the angle of images. So that was a really great experience. And then I'm just going to go over the last part of the actual course, and that actually goes over the Google's page rank algorithm. Sorry about the starting today; I'm a little tired. So essentially, what the page rank algorithm is it just, the goal of it is to rank websites based off authority. The more links directed to that website, the more authority that site has. So a good example would be, if every blog is talking about the best site to, have an online resume is LinkedIn, Google's going to say, hey, well, that site tends to have a lot of links directed towards it. Maybe that site has authority. And if a lot of websites are sending links to that site, like I said in this example, I used LinkedIn, Google would rank that higher in the engine. And you basically learn using linear algebra how to rewrite this algorithm. And they do help you a bit. It's not like you're writing the entire thing from scratch. They already have some of the code pre-written, but you do have to fill in the blanks. And you can see here on the right hand side, they're showing you website A, website B, website C, website D, and they're showing, and these lines represent links. Um, Overall, I just want to summarize. This was really just a quick little thing I wanted to go over for the course. You take this course and your goal is to learn math, you're going to have a great time. If it's to learn libraries, not so much. But again, that's not what they're advertising anyways. Free course, you don't have to pay for it. If you want a certificate that you could post on your LinkedIn account, then you can pay for it. I think it's 60 or 70. I think it's 60 or 70. No, I think it's like, yeah, it's around, don't quote me, but I think it's around 50 to 60 bucks a month. And as you can see, it takes around 5 weeks. So I think it ends up being around, a bit over 100 if you want to get a certificate. Of course, you definitely don't have to finish it in 5 weeks. You could easily finish this course in 3 weeks if you focus, not hard at all. But yeah, anyways, guys, that's all I'm going to say about mathematics and machine learning. You can find this course over here on Coursera. I'll post a link. Like I said, it's free. If you want a certificate, you have to pay. If you liked the video, please like. If you have any comments, leave it down in the comment section. I know that online learning, there's great courses and there's terrible courses, and I'm hoping that someone sees this video and they're contemplating taking this, they'll be able to kind of discern between the great courses and the bad courses, hopefully save them some time. Anyways, guys, thanks again. Please leave a like I said, comment, subscribe, and have a great one.